Okay, so tonight for homework, you have the tape diagram assignment, and you should have this handout right here on tape diagrams, folded like a book, and it opens up like this, okay? So you should have that video, but to do tape diagrams is pretty much like how we did with the double number line, except we're using like a box, okay? So in the first example on your homework, it says that Emily created a new drink by mixing 2 parts melon juice with 3 parts orange juice. If Emily used 18 ounces of melon juice, how many ounces of orange juice would be needed? And this is a sheet that you have that I'm referencing right here, the one about practicing solving ratios using tape diagrams. You were given this in class. So this is the sheet that I'm using. And I'm doing the example on that page. So this is the example. So we know that we're going to have melon over orange juice. And we're going to have melon over orange juice because that's how it was given to me. 2 parts melon over 3 parts orange juice. So that's why I just put melon on top, orange juice on the bottom. It doesn't really matter which way you put it in this particular example because you're trying to figure out how many ounces of orange juice will be needed. So it told me that I want to end up with 18 ounces of melon juice is what I'm going to use. So
Route 15, your ride has arrived. Route 15. You may go ride your bus.
So because I want to have 18, because 18 was given to me in the problem, I know that these two, and I'm having 2 parts melon juice, I know that these two numbers right here need to be something that will equal 18. And they have to be the same, because these all represent the same amount. So in order for these two to be the same number and be 18, both of them need to be a 9. So 9 plus 9 equals 18. That gives me 2 parts of melon juice. Well, if this is 9, this box and this box is the same. So this will be 9, this will be 9, and this will be 9. So if I have 18 ounces of melon juice, 9 plus 9 is 18, then I have 9 plus 9 plus 9 parts of orange juice, ounces of orange juice. And 9 plus 9 plus 9 makes 27. So in this tape diagram, orange juice will be 27 ounces. I would need 27 ounces of orange juice. I can also look at that as a proportion. So melon juice is 2, orange juice is 3 ounces. Well, I know that I'm going to use 18 ounces of melon juice. That's given to me in the problem. 18. It says if Emily used 18 ounces of melon juice, how many ounces of orange juice will be needed? So just like we talked about in elementary school, you would have 2 over 3 is equal to 18 over box. Well, how would you figure out what the box is? Well, you'd figure out how do I go from 2 to 18. Well, this will be times 9. Whatever I do to the top, I have to do to the bottom. So this will be 3 times 9. 3 times 9 is 27. And that's the way I can check to make sure that I'm right. The next example, number 1, well, the next problem, the first problem, says, for every 5 calendars that Austin sold, Laura sold 4. Austin sold 45 calendars last month. How many calendars did Laura sell? Well, I have Austin over Laura. I know for every 5 Austin sold, Laura sold 4. They also told me that Austin sold 45. So I'm going to start with 45, and I'm going to represent this number in boxes. So I have 5 on top, so I'm going to draw 5 boxes. I have 4 on bottom. I'm going to draw 4 little boxes to represent Laura. Now, I know that these all together have to equal 45 because the problem told me that Austin sold 45 calendars. So the question is, what number can I put in here that I'm going to write 5 times so that I can get 45? It can have a total of 45. So 9 will be my number. So I'm going to put 9 here, 9 here, 9 here, 9 here, 9 here. And if I do 9 plus 9 plus 9 plus 9 plus 9, or an easy way to be just 9 times 5, I will get 45. If all of these boxes are 9, all of these are also going to be 9. So all of these represent the same part. So these will be 9, 9, 9, and 9. These all represent the same amount. So if Austin sells 45 calendars, then Laura would sell 9 plus 9 plus 9 plus 9, or 9 times 4, which is 36 calendars. So my answer here would be 36 for Laura. Now, if I want to check that, I could just set up a proportion. Remember, proportion is nothing but equivalent fractions. Well, my ratio of Austin to Laura was 5 to 4. So I'm going to put 5 over 4 equals, the problem told me that Austin sold 45. Since Austin is on top over here, Austin has to be on top over here. And I don't know Laura. So how did I go from 5 to 45? Well, 5 times 9. Whatever I do to the top, I got to do to the bottom. So this will be 4 times 9. So x is equal to 36, which is the same thing I got right here. All right, let's look at another one. Problem number 2. In problem number 2, it reads, for every 3 cars that Kelly sells, Jane sells 4. Jane sold 32 cars, so I know the total amount that Jane has sold already. How many cars did Kelly sell? So I'm going to take, and I wrote Jane over Kelly. For every 3 Jane sells, Kelly sells 4. So this ratio is 3 to 4 here. I know that Kelly sold 32. So I'm going to put 32 on the bottom in the proportion. Well, I'll hold off on that. Well, I'm going to represent this number in bars. So I'm going to put 3 bars here and 4 bars here. And I know that 32 is the amount that Kelly sells. Kelly is on bottom. So I'm going to ask myself, what numbers can I put in here that when I add them all together, I get a total of 32? Because this is for Kelly. This is Kelly's amount. And I need for all 4 of these numbers right here to add up to give me 32. Well, I can use 8, 8, 8, and 8. Because basically I'm thinking 4 times what makes 32? Well, 8 times 4 makes 32. And if these are all 8s, then these have to all be 8s. So Jane, if Kelly sells 32, then Jane is going to sell 24. So Jane is going to be equal to 24. So this will be 24 over 32 as the 2 equivalent fractions or the proportion. Now using the proportion, I could have said Jane over Kelly, which is 3 over 4, is equal to, I don't know Jane, so she's going to be box or x. We say in 6th grade, we say box in elementary, and we say x, a variable in 6th grade. And then we put 32 for Kelly because it was given to us in the problem. They told me that Kelly sold 32 cars. So then I have to say, how did 4 change to a 32 times 8? Whatever I do to the bottom, got to do to the top. So 3 times 8 will give me 24. And that's how I got the 24 for Jane. The next example, the next problem, problem number 3, says the ratio of boys to girls who participated in the pie eating contest was 7 to 2. Boys to girls, 7 to 2. And then it says there were 35 boys. So this 35 is representing boys right here. So I know that I need to draw 7 parts. And each one of these parts added together needs to be 35. So these parts are actually identical numbers. They should be even. And I know they don't look even. That's because I can't draw very well. But they are even pieces. They are all the same size. So I'm asking myself, what number can I add 7 times or multiply by 7 and get 35? And that answer is 5. So 5, 5, 5, 5, 5, 5, 5. If all these are 5, then these 2 are also 5 because they're the same amount as these, each one of those. All right. So then I can figure out how many girls. If there are 35 boys, then there is only going to be 5 plus 5 girls, which is 10. And I can check that using a proportion. Boys over girls equal boys over girls. And the problem told me that there's 35 boys, and I don't know the number of girls. That's the mystery. So that's why I put an X there, a variable. So what did I do to 7 to get 35? I multiply by 5. Whatever I do to the top, I have to do to the bottom. 2 times 5 is 10, so X equals 10, which means if there's 35 boys, there are 10 girls. Last one that I'm going to do from your homework sheet is problem number 4. In problem number 4, it reads, the ratio of the length of Grace's string to the length of Peter's string is 5 to 6. So Grace, 5, Peter, 6. So all I did was take this number and draw in boxes. 5 boxes, 6 boxes. Okay? And then it goes on to tell me that Peter's string measured 60 inches. So for Peter's string, I just wrote a 60 and I'm thinking, okay, Peter is on bottom, so I'm looking here at this number. What number can I add 6 times and get 60? Because I know Peter's string is 60. So my 6 boxes have to all add together to give me 60. So this represents Peter. Grace on top, Peter on bottom. Well, a number that I can add 6 times and get 60 is 10. So this will be 10, 10, 10, 10, 10, and 10. Well, if these are all 10, then these are all the same size. They're all equal. So those are also 10. So when Peter's string is 60 inches, then Grace's string is 10 plus 10 plus 10 plus 10 plus 10, or 10 times 5, which is 50 inches. And I can check that using this proportion. Grace over Peter equals Grace over Peter. I don't know Grace, but I know Peter is 60. So then I say x over 60, or x divided by 60. Well, 60 times what? 6 times what give me 60? Well, that'll be times 10. Whatever I do to the bottom, got to do to the top. 5 times 10 is 50, so x equals a 50. So when Grace's string is 50 inches, Peter's string is 60 inches. Now, you have to continue using this to do your homework. Finish 5 through 10 on this sheet that you got in class today. And make sure you draw your tape diagrams out so I can see. Show your work, and good night. Let me know if you have questions tomorrow, and I'll be glad to help you. Good evening.